Welcome. This session is going to be a quick introduction into how we understand the way that people make choices and how we can use that insight to create better products, services, and experiences for content analysis. So let's start off by thinking about how we actually make choices. Let's take toasters as our first example. A toaster might seem like a simple product to choose, but when we look a little bit deeper, we can see that deciding which toaster we should get can require us to think about a multitude of factors. We need to consider how many slices of bread each toaster can make at once, what color it is, how much space it'll take up in our kitchen, and even whether we want a toaster that can poach an egg or play a song when it's done. Another example might be which mobile phone we should buy, something which is not trivial at all now that we are so dependent on them, and having to consider things like how much storage we want, how big of a screen we're looking for, and if we want to stick to a familiar brand that we can trust, camera quality, color, warranty, it can all be a lot to take in. And finally, some decisions go far beyond simply choosing a product, like for example, deciding which bank to open a debit or credit card account with. In these cases, we have to weigh important factors such as interest rates, rewards programs, and fees alongside wider concepts like reputational factors or even the likelihood that the bank will accept our application in the first place. The point that we're trying to make here is that whenever we make decisions, we have to consider a wide range of information about the options available to us. Whether the choice is serious or seemingly trivial, our decision-making process is often far more complex than it appears. When looking at how we make choices in the context of market research, we need to recognize that consumers and producers often have opposing objectives. From the consumer's perspective, the priority is often value for money. People want to feel they are getting as much as they possibly can from what they pay, and a product loaded with high quality features yet offered at the lowest possible price is always going to test exceptionally well. It's human nature for us to want the best deal available and to stretch every dollar as far as it can go. Producers, on the other hand, see the exact same exchange from the opposite angle. Their aim is to maximize the profit on each purchase, which means carefully balancing how much it costs to create the product against the price they can reasonably charge for it. This is not simply about covering costs, but about ensuring that the margin between production and the sale makes the entire enterprise worthwhile. In the end, the ideal outcome lies somewhere in the middle, a balance where consumers feel they are getting genuine value and producers can sustain a healthy profit. So how can we begin to understand consumer choices? A common method would be to ask direct questions like, what is your preferred brand? What price do you think would be reasonable for this phone? Or not at all dull questions like, how many slices of toast do you want your toaster to be able to handle at once? Additionally, not all features that we consider when choosing what to buy carry the same weight of importance, and as such, we also need to understand which features people focus on the most when choosing a product. And so we could also ask direct questions on importance, like how important is the interest rate or annual limit when deciding which credit card you should get. However, these importance ratings and direct questions tend to not be particularly helpful in giving us insights into people's preferences and decision making. They often lack discrimination between the things we are actually trying to understand, and we end up with data where people select very important for a lot of features. This is really because they actually feel like these elements are all important to them. And because we aren't really asking them to trade off these measures in any meaningful way, they can simply tell us that. But without trade offs, we struggle to understand the relative importance among similarly important items. The real thing we want to understand is how important each feature is relative to our other product features. Finally, the data we get from these questions is not particularly actionable in the first place outside of segmentation studies and doesn't really allow us to determine what will be the ideal product for consumers. So, what is content analysis and how can it better help us understand these questions? Conjoint is a research technique originally developed in the 1970s, and its primary objective is to essentially measure people's value for the individual features of a product or service. The word conjoint derives from the fact that consumers consider if they would purchase a particular product as a result of considering each of its individual features at the same time or conjointly. How it works is that we define our product's independent variables, like brand, color, and price. And each of these variables, which we call attributes, will take on multiple possible values, which we call levels. So price, for example, we would have a list of all possible prices that a person could be shown, like 199, 299, 399, and so on. And size, we could simply have definitions like small, medium, and large. During the actual conjoint experiment itself, we will show different products that are represented by different systemically varied combinations of these attribute levels. In other words, we are showing them different combinations of brands, prices, sizes, and colors, and asking the respondent to indicate which they would choose if these were their options. To add a more visual explanation about this would be an example of what a very basic conjoint task would look like. In this example, we are looking at people's preferences for cars, and our independent variables are horsepower and fuel consumption. Instead of just asking people in a very basic way if they care more about horsepower or fuel economy when purchasing a car, we instead present them with two products of a systemic combination of a level from our horsepower attribute and another from our fuel consumption attribute. The product on the left has great horsepower, but consumes far more fuel per gallon, while the one on the right is exactly the opposite. By presenting it in this format, we force the person to make a trade-off decision: sacrifice fuel economy for more horsepower, or sacrifice horsepower for more fuel economy. That way we can gauge the person's true relative importance and preference for these features when they are purchasing a car. The key aspect here is that we force the respondent to make a trade-off decision. We don't allow them to say that everything is important, and instead we present them with an experiment that mimics real-world decisions, where they are presented with difficult situations. As an output, we get something called a utility score for each level of our attributes. These scores provide us with an insight into what is the relative preference for each attribute level relative to other levels in the same attribute. For example, if we had an attribute in a car conjoint called color, and blue had a utility of 3 and green a utility of 1, we could say that blue is far more preferred than green. However, this does not mean that people hate green, just that it's less preferred over blue. Conjoint can be applied to far more than just pricing research, and it can be a useful tool when wanting to determine preferences for anything. For example, a business school can use Conjoint to find how to best change its program features, such as course offerings, campus facilities, to influence the number of applicants, or how to help city planners understand residents' trade-offs between preserving parks and allowing new housing or commercial development. Conjoint has even proven to be exceptionally useful in Caribbean islands that depend on scuba tourism, where we reveal the tipping point where more divers bring in more revenue but cause enough reef damage to drive divers away. This case study here is a great example of how conjoint analysis can be applied well beyond pricing research. After the dot-com era, Microsoft needed to retain and attract highly skilled, talented people, but couldn't just throw unlimited money at the issue. They needed to find a way to keep employees satisfied with their compensation, reduce turnover, and still control costs, which is a pretty tough balancing act. Instead of guessing what employees value the most, they just used conjoint analysis to identify and quantify the specific drivers of job satisfaction. The study measured how different elements, salary, bonuses, stock options, health benefits, flexible work arrangements, and other perks influenced employees' overall satisfaction and likelihood to stay. Because Conjoint forces respondents to make trade-offs, it reveals the real priorities, not just what people say they want. Once they had those utilities, Microsoft simply overlaid cost data for each benefit. This allowed them to model different benefit packages and find the combination that maximized employee satisfaction for the budget that was available. The outcome was a far more efficient, evidence-based approach for compensation, focusing spending on the benefits that delivered the highest value for employees whilst reducing waste and low-impact perks. We've been talking a lot about why you should use conjoints, so let's get into how we can actually build a conjoint model. We've talked before about attributes and levels in the context of conjoint analysis, but let's go a little bit deeper into what they actually are and how we can define them. Attributes are the independent aspects of a product or service that influence choice. Think of things like brand, speed, color, and price. Each is a distinct dimension that matters to the decision maker. Levels, on the other hand, are the specific variations within each attribute that we want to test. For example, if our attribute is price, the levels might be $5, $6, $7. If our attribute is brand, the levels might be Coke, Pepsi, and Sprite. The key here is that the way we define attributes and levels determines the quality of our conjoint results. Clear and realistic options gives us more accurate insights, while poorly chosen ones can lead to noise and misleading conclusions. So let's go a little deeper into attributes. These are the independent aspects of a product or service that can influence the choice, as we mentioned. And how many attributes we should have depends on the research objectives. There's a common misconception that respondents can only handle a small amount of information, but in reality, with well-organized grids and clear visual representations, people can process more attributes than we once thought possible. One important rule, however, is that attributes should be independent. If we have attributes like quality and product life expectancy, we need to ask ourselves, are they separate dimensions or are they all just measuring the same underlying factor? Redundancy in attributes can dilute the insights we get from the study and also confuse respondents, or lead to each person interpreting the products we are showing them in vastly different ways. These attributes also need to be relevant. Including attributes that people do not generally consider when making their choices can be detrimental to the accuracy of our results and add noise to our data. A good example to illustrate this would be adding an attribute like weight in a mobile phone conjoint. Phone brands often advertise how light a phone is, but this is not actually a factor people actively think about, since most phones have the same or practically unnoticeable difference in weight. Think about how many times you have gone to buy a phone and actually started weighing different models in your hand to see which was heavier. The answer is probably never. Introducing this attribute in such a study would force people to consider something in their choices that in reality they would never truly think about. Moving on to attribute levels. It's important to remember that they should always be mutually exclusive. A single product or service can only have one level for each attribute, so if the printer is red, it's also not green or blue at the same time. Another key point that's often overlooked is if it's possible for a product to not have a certain attribute at all, we need to explicitly include a not present level. That way, our design still captures that possibility in the choice data. Well-chosen levels make our conjoint scenarios realistic and ensure that trade-offs we're testing reflect the actual decisions people make. Let's look at this quick example. Suppose our attribute is add-on features. The levels might be sunroof, GPS, and DVD player. If we define them this way, our analysis will tell us the value of having one of these features, but the limitation is that we can't really determine the value of having two or three of these features together. So, when we're defining levels, we need to think ahead about whether features should be tested separately or whether combinations are possible and relevant. This is one of those small design choices that can make a very big difference in the insights we get. We could instead create three separate binary attributes called sunroof, GPS, and DVD, where the levels for each are included or not included. Or we could even design an attribute which included every possible combination of these three items. This would then allow us to simulate people's choices for a combination of these three different add-ons. Another key point is that levels must be concrete and unambiguous. For example, a vague level like very expensive leaves far too much room for personal interpretation. What's expensive to one person might not be to another. Instead, use clear, specific levels like $575. Similarly, saying weight 5 to 8 kilos is ambiguous because respondents might imagine different weights within that range. It's much better to be precise. It's also important to remember that we can interpolate between levels. So, if we were interested in a large range of prices, like for example ranging from $1 to $50, we don't have to test all 50 price points. We can just test a few precise prices within that range and then interpolate between them. There isn't necessarily a rule of thumb for how wide the gap should be, but you should always try to avoid making them too wide and also keep them equal. It's also important to consider, especially with prices, if there are any psychological points, like, for example, the gap between $1.99 and $2 is small, but people do have significant preferences for prices displayed with a 99-cent mark over the whole rounded prices. The point here is that using clear, exact levels, we ensure that everyone interprets the attribute levels the same way. So, what do we actually get out of conjoint? Let's start off by talking about one of the most important building blocks of a conjoint model: utilities. Utilities are sometimes called part words because each value represents the worth or contribution of a part of the overall product, like a single attribute level in our case. When you add up the utilities for all the chosen levels of a product, you get the total value or preference for that product in the eyes of the respondent. Utilities are essentially just numeric values that tell us how desirable each feature is to an actual respondent. For example, imagine we tested ice cream flavors. Vanilla has a utility of 2.5, while chocolate scores 1.8. And if we look at price, 25 cents has a score of 5.3, 35 cents has 3.2, and 50 cents scores only 1.4. This is telling us the order of preference for each of these levels when people are making choices. The key here is that the higher the utility value, the more preferred the feature is. These numbers are what allow us to compare features and make informed trade-off decisions in product design. One important thing to remember about utilities is that they're interval scaled. This means that we can't make direct ratio comparisons between them. For example, if vanilla has a utility of 2.5 and chocolate has a utility of 1.8, it doesn't mean vanilla is 1.4 times better than chocolate. The numbers here aren't absolute measures. They're just relative within their scale, since they indicate people's relative preference for each level, not their absolute like or dislike for something. This also means that we can't directly compare the utility value from one level from one attribute to a level from another attribute. What we can do, though, is compare differences. The difference between two levels within one attribute can be compared to the difference between two levels within another attribute, because those differences represent the relative importance or preference change. Now let's discuss importance scores. These are ratio scale values, which means that we can compare them directly across attributes. Importance scores measure the potential influence each attribute can have on the choices people make, and they're calculated by taking the difference between the utility of the best level and the worst level within each attribute. Once we've calculated the difference for every attribute, we express it as a percentage of the summed range across all attributes. Let's take this example here. For the flavor attribute, the difference between vanilla at 2.5 and chocolate at 1.8 is 0.7. For price, the difference between 25 cents at 5.3 and 50 cents at 1.4 is 3.9. If we add those differences together, we get a total of 4.6. Now we express each attribute's difference as a percentage of the total, and in this case, flavor accounts for 15.2% of the decision, while price makes it 84.8%. It's important to note that these scores are shaped by the range of levels you choose for each attribute, and how many attributes you include in your study. If the levels don't vary very much, the attribute's importance will naturally look smaller, even if it's something people actually do care about in real life. Once we have the utilities from our conjoint model, we can start running market simulations, essentially creating what-if scenarios to predict how the market might respond to different situations. For example, we can estimate at what price people might switch to a competitor and away from our product. We can test if we could modify our product to cut costs but still maintain market share. We can also simulate whether it's smarter to launch a high-end product, a budget model, or even both. And importantly, we can assess whether introducing something new cannibalizes our sales, taking customers away from our existing products rather than growing the market. Essentially, market simulations turn numbers from conjoint into actionable business decisions. Now, let's look at this simple market simulation here as an example. Just to set the stage, we're focusing only on the utilities for the first two respondents. These utility values represent how much each respondent values different product features, in this case, ice cream flavor and price. For example, respondent 1 assigns a higher utility to vanilla than chocolate, and strongly prefers a lower price of 25 cents. Respondent 2, on the other hand, prefers chocolate and also favors a lower price. We can then use the utility values to simulate which product each respondent would choose between a 35-cent vanilla cone and a 25-cent chocolate cone. Now let's look at the full market simulation using 500 respondents. We're comparing two products here, a 35-cent vanilla cone and a 25-cent chocolate cone. Using the first choice rule, where each respondent picks the option with the highest total utility, we find that 65% of respondents prefer the 25-cent chocolate cone, while 35% prefer the 35-cent vanilla cone. This gives us a simulated market share, or share of preference for each product based on the utility data. When we are interpreting the results of our conjoint market simulation, it's important to understand the assumptions behind it. Firstly, we assume that we have interviewed the right people, which means that we believe that our sample of respondents accurately represents the target market. If you're simulating preferences for cars, for example, your respondents should be actual or potential car buyers. Secondly, that all attributes which affect buyers' choices in the real world have been accounted for, meaning the conjoint design includes all the key product features that influence decisions. If an important factor like brand or packaging is left out, the simulation might not reflect real-world behavior. Thirdly, that all products in simulation are equally available in the market. If one product is harder to find in stores than others, that would affect real-world choices but isn't reflected in the simulation. Fourthly, that there are zero barriers to switching. And finally, we make the assumption that respondents are equally aware of all products, while in reality, awareness can vary. Another important point to remember is that the shares of preference we get from conjoint simulations don't always match actual market shares. And that's actually okay. There's a few reasons for this, and firstly it is because the simulator is built on this set of assumptions we were just talking about, like equal availability and awareness that don't always hold up. But that doesn't make the simulation any less valuable, especially since we can feed this information into the simulator if we have it. What the simulator ultimately does is translate abstract utility scores into concrete predictions about the preference shares, assuming a level playing field. This helps us understand how people make trade-offs between features, even for products that don't yet exist. So while the numbers might not match real-world sales exactly, they give us a powerful insight into consumer preferences and decision making. Thanks for sticking with us throughout this intro to content analysis. And if you'd like to keep learning, feel free to check out our other free resources we've got all across the website.